All right, so for Monday, here's the assignment. It's set 3N for problems 4, 5, and 6. Now that's in your packet right here. Problem 4, 5, and 6. All right, so what we're doing today is we're transforming from different forms of a quadratic. So we've talked about a quadratic can be written in general form. It can be written in vertex form. And it can be written in intercept or factored form. And each one of these forms gives us different information about a quadratic. And you can change from one to the other. So we could go from general to vertex. We can go from general to factored, and vice versa. You can change it from factored back to general, factored back to vertex, vertex to factor. I mean, you can switch between any of them. Then the other thing that we'll do, the second part of this lesson, is just when you have a graph that's written in one of these formats, I wrote out the steps on how to graph them. Okay, so like Jacob, you were asking about this. So when we get to this part, you'll see a page, it'll say, hey, if it's in general form, this is how you graph it. If it's in vertex form, here's how you graph it. Okay, if it's in factored form, here's how you graph it. So it'll give you step-by-step instructions, and as you fill it out, you'll have an example. All right. Then after that, we're going to take a parabola and fit a curve to it, come up with the equation. So if you know the picture of the parabola, what's the equation that goes with it? So that's the last part. All righty. So this first part, like I said, is a review of Algebra 1. Okay, and a review of some factoring here. All right. Okay, so this first one here you guys got, that's in factored or vertex form. And we want to change it into general form. All righty. So it's really easy. All you're doing is expanding it. Expanding means multiply anything out and then add your like terms. Okay, so to expand, in this problem, here's our A value. A is 1. This tells us H is -1. This tells us that K is -3. Over here on this one, this tells us A is -0.5. Q or P is 3. And Q is -4. Okay, questions on how I'm getting that? Okay, put your phones away, because then you ask me silly questions on the quiz. I don't mind questions, but when it's something that I've done in class, then I mind. Yes. because I messed up. No wonder you're having problems. If I teach correctly, you'd be all right. Yep. Yes. What? Because when something is to be written in vertex form uh, looks like this. Let's see. Vertex form is ax minus h plus k. So if you have to rewrite this so it looks like that. So if you did, if I wrote that so it looks like this, I'd have to make this h a -1, because a negative and a negative make a positive. So x plus 1 is the same as x minus -1. When it's written like that, it reveals the true value of h. So if it was already x minus 1, you don't have to do that. Now h is 1. Okay. Yeah, we all just got to speak up a little because we're all a little muffled. So it's hard to hear. Okay. So once we got that, now you're just going to expand this. So over here, I'm going to have y equals, now just a bunch of algebra. Okay, when you expand a binomial, like if I had x plus 1 cubed, to do that, I'd have to write it 3 times. And now I'd have to do a whole bunch of multiplying. Now later on, we're going to learn a shortcut to doing this, using Pascal's triangle of all things. So on this one here, you don't really need a shortcut because it's only 2. So I'm going to rewrite this part as x plus 1 times x plus 1 minus 3. And now you multiply out those x plus 1s. So that's an algebra 1 skill. X times x, x squared, x times 1, 1x, 1 times x, and then 1 times 1. Then I got 2 like terms right here. Put those guys together. Okay, now distribute the 2 through these 3 terms, and then the 2 doesn't affect the 3. And then I end up with y equals 2 x squared plus 4x. And now it's in general, it's in this format. It's the same thing, it just looks different. So we call that a transformation. Yes. This here? Okay. That's called FOIL. I don't know if, do they still teach you guys FOIL? No? You haven't? This was back in my day. We were big into acronyms. Okay, so FOIL stands for first. So you multiply the two first terms, x times x, x squared. Then the O stood for outer. So then you multiply the two outside terms, x times 1, that's x. Then the I stood for inner. So you multiply the two inside terms, 1 times x, x. And then you did the last terms. 1 times 1 is 1. So how did you guys make a box? You box it? No. You just distribute, yeah. Distribute. When you distribute, that's FOIL. We just put a name to it. When I have extra time, ask me about my interesting story about acronyms. When I'm done, it'll blow your mind. So one day that we're done early, ask me about the acronym story. No, I'll get way off track. But it is really interesting. All righty. Well, good. I'll leave that hanging there. Okay. All right. So that's how I multiply those two terms. Okay. Thumbs up. Okay. All right. So actually, Jacob will have you do this one because we're going to do the same thing. Oh, by the way, when we're here now we know A is 2, B 4, C negative. Okay, so first, so I'm going to have, I'll have y equals negative 1/2. Okay, multiply your first terms, Jacob. Yep. Okay. Done. Outer terms. Correct. Inner terms. Correct. And last terms. Yep. There you go. FOIL. Okay, then I got a couple of like terms. I combine those guys. So that's plus x minus 12. And now I'm going to distribute the 1/2 through. Everything gets multiplied by negative 1/2. Half of 12 is 6. and now it's transformed. A, -1/2, B, and C is 6. Yes, sir. No reason. It's just a way to group it. That's all. No, well, I mean, there are times where brackets have meaning. You know, when we did interval notation, you know, if I was saying, you know, what's the range of this? This was -3. Well, the range is -3, includes -3, then it goes to infinity. So in that case, a bracket has a specific meaning. It includes this number. And here, it's just a way of grouping. That's all. And so instead of having, I use it when I have like parentheses and another set of parentheses. But other than that, in this particular context, there's no difference. Okay, now factoring. So factoring is the reverse of foiling. Okay, so foiling is putting an equation together, so to speak. Factoring is taking it and breaking it down into its basic parts. So if you take something apart, you're literally factoring it. Okay. All right. So I put different difficulty factoring problems up here. When we're done, we want all of these to end up looking like this form. Okay, now there's a couple of particular things that you got to keep in mind. If you look at the x's here, there's no numbers in front of them. It's just 1x. So if you had factored it, if you did all your work and you ended up with something, let's say like this. Okay, that looks a lot like factored form. The problem is this has to be a 1, not a 5. So you can't leave it like that. That would not be in factored form. So to get rid of a coefficient, you just divide the whole thing by that coefficient. That's factoring. So if I pulled this 5 out of that binomial, what I'm doing in my head is this. I'm dividing that by 5, and I get x. And I'm dividing that by 5, and I'm getting minus 6. And then that would be 10. Now it's in factored form. Now it's in the correct form. Okay, yes. Correct. It has to have the x's have to have a coefficient of 1. Coefficients are numbers in front of letters. That's a coefficient. So coefficient needs to be 1. All right, now, when you're factoring, here's your basic factoring back from when you were freshmen. Okay, when you look at this, your A value is 1, your B value is 2, and your C value is 24. Now this has a typo in it. Make this plus 24 a minus 24. That was a mistake on my part. All right, so A is 1, B is 2, and C is 24. All right, when the coefficient on the squared term is 1, like this one, these are the easiest factoring ones. Okay, you can factor them pretty darn quick. Okay, the method that I use is called, I call it the factor game. So I make a giant X. All right, I'm going to have the top number be A times C. So 1 times negative 24. The bottom number is B. Okay, so what I'm looking for is a pair of numbers that when I multiply them, I get negative 20. And when I add the same two numbers, I get positive 2. 6 and 4, and one of them's got to be negative. Okay, so 6, 4, and I got to make the 4 negative, so when I add them, I get the 2. Okay, so the numbers, the other way I write it is they got to multiply to be this guy and add to be this guy. All right, so that's 6 and negative 4. Now, the cool thing is you're done factoring. You can write this as 2 terms, and you just take your numbers from the factor game. That's a positive 6, so that's a plus 6. That's a minus 4, so that's minus 4. And it's factored. Okay, so in this case, your A is right there. A's 1. P wouldn't be 6 because it has to be written as minus P. So P is actually negative 6. And Q is... Now, the other way to think about that, to get P and Q, is what makes this equal to 0? Negative 6. What makes this equal to 0? Positive 4. That's your P's and your Q's. So that's pretty simple. All right, now the next one we're going to do is this one in the lower right-hand corner. Because it's just like this one, but this is no longer 1. Now it's a 3. So it takes a little extra work than this. All right, so I draw my X. Okay. So what do they have to multiply together to be? Anyone? Not? It's not 10. Remember, this is A times C. 30. Because of this. So that's why this one requires a little bit more work on it. Okay, what you need? I'm in the middle of factoring here. Come on. Jaden, to your room. This is like being texted from my daughter texted me from the other room in the house.
I bet it's Carly.
All right.
It's Carly.
Okay. All right. I'll send her over. Mr. Carlin wants you. Jeez, what a waste. I just wasted 30 seconds of my life there because he couldn't get up out of his seat. That's like my daughter texts me from her bedroom. I'm like, I'll never respond. I'm in the other room. Walk out. Do you guys text your parents from within your house?
Yeah, all the time. My mom tells me when dinner's ready.
Yeah, that's how my mom texts me when dinner's ready.
She's like, hey, dinner's ready.
Yeah, and then she comes out, you didn't text me back. I'm like, I'm not texting 20 feet.
Well, hey, because you didn't respond. Shut up.
Yeah, crazy. Hey. All right, so this is different. That's because of that 30. This is the middle term. All righty, so now we got like a 6 and a 5. So 6, 5, that's going to make 30. And now for it to make negative 11, I'm going to make all of these. Okay. Now, in the previous example, what we did was we factored that. Once we had those numbers, we could write out both factors. You can't do that here because this is no longer a 1. So this is where the way people teach it changes. How do you deal with that? So what I do is I make a box. So I'm going to draw a 2x2 box. And I'm going to use the box to help me figure out what those factors are. Okay. And y equals now, if that 3 wasn't there, I could just slap the -6 in and the -5 and be done. All right, so I'm going to color code with a highlighter where these things go. So the 3, that goes in the upper left. The constant goes in the lower right. Over here, I'm going to write 3x squared. Down here, I'm going to write 10. So I guess I could have colored these. That's where the green ones go. Now, the 2 numbers that you came up with, they go in the other 2 places. With one addition, you're going to put an X on them. Okay, now what you're going to do is you're going to GCF the rows, and then you're going to GCF the columns, and that's going to give you what goes here. Okay, so the greatest common factor between 3x squared and -5x is just x. So I'm going to write an x out there. Okay, greatest common factor between -6x and 10 is 2. Since the first term's negative, I'm going to factor out a negative. Now I know my first term up here. So what we're doing is these two things are our GCFs, greatest common factor. Okay, now you're going to do it for these two columns. So these have an X in common, and the GCF between those two terms is 3. This is going to be 3X. Now the GCF between 5 and 10 is 5. Since this is a leading negative, pull out negative 5. And it's factored. Okay, now the only thing left to do is we're not allowed to leave this for this form. That can't remain a 3. We got to change that to a 1. Yep. So in my head, really what I'm doing is I'm dividing this by 3 and that by 3. That's what's going on. So to represent that, when I pull out a 3, I factor out a 3. Pulling a 3 out of this, that would be X, and that would be negative 5. Now it's in intercept form. These would be the x-intercepts of your parabola. Okay, so A, 3, P, 2, Q, 5. All right. Questions? And now the other two, they have GCFs at the beginning. So this one has a GCF. Get rid of that first. You pull it out. You don't get rid of it. You just divide everything by the GCF. So I don't write this, but in my head, what I'm doing is I'm dividing this term by, since that's a leading negative, by -2, by -2, by -2. That's what's going on in my head. So when I do that, I write -2 out front. Then I'm left, everything gets divided by -2. Yes. Right. The other ones didn't have any GCFs. GCF for that is 1. And the GCF for the one on the lower right is also 1. You always start with GCF. That's always your first step. Greatest common factor. All right, so this would be positive 2x squared minus 9x plus 4. So this got everything in it. Now you got to go through the box. Now it's just like the problem we did. Got to multiply together to be 8. 2 times 4. And it's got to add together to be -9. 8 and 1. Negative 8. Now, if that darn 2 wasn't in front of that x squared, we could just drop those in. Okay, so these two go here, here, and these two guys. Negative 8 with an x, 1. Nope. You could switch these two. It doesn't matter. I always do these two the same. Probably wouldn't matter. It wouldn't matter the other way either. But with the 8 and the negative 1, doesn't matter. Okay, GCF it. So I got a leading negative, negative. These both have an x in them with a leading positive. X minus, and now do your columns. These share a 2 and an x. And these just share a 1. And since the leading term is a negative, the first term's a negative, I'm going to factor out a minus. So the way the box works, you know you did it right if you it's like a multiplication table. If you multiply these two terms, you get 2x squared. If you multiply these two terms, you get negative x. If you multiply these two, you get negative 8x, etc. Okay, almost done. We just got this 2 right here you got to get rid of. So there, we're going to factor out a 2. Now that 2 comes all the way out front. So this is really going to become negative 4 now. X minus 4, and if I divide that by 2, I get x. If I divide that by 2, I get All right, that's factoring. You spend like all of Algebra 2, you spend a lot of factoring in Algebra 2, I take it, Algebra 1. But it's like learning how to take a carburetor apart. You're factoring it. You're breaking it down into its most basic pieces. All right, we'll start on the next part of this. We won't get through it. All right, so what we've done so far, we've taken vertex and factored, changed it into general. That was just multiplying out. To go from general to factored, we had to factor it. Oops, we missed one. Do this guy real quick. Okay. GCF it. So leading negative, let's pull out a negative. Okay. In my head, I'm doing this. 1 by 2x. And I'm dividing that by negative 2. So factoring is dividing. Okay. Now you got to get rid of that 2. So that 2 is going to come all the way out front and make that a negative 4x. Divide that by 2. Divide that by 2. Now it almost looks like this. Okay, so to get it to look exactly like that, you're going to rewrite x as x minus 0. Now it's in factored form. Negative 4 p 0 q. Okay, so tomorrow we'll pick up with how to take something that's in general form and convert it to vertex form. And then you'll be able to do all the entire